Okay. Sure. Okay, perfect. That sounds better. Awesome. Thank you very much. Should be good to go. All right. So I'm Andrew Seier. I work for Plotly. This is Marianne Corvellec, also works for Plotly. We're going to talk about things related to Plotly and data visualization, and then also just in general, we're going to talk about visualizing in Python. So this is kind of like a broad overview, and we'll dig into some specific spots along the way. So this is called Making Beautiful Graphs in Python and Sharing Them. I sent out an email earlier about a GitHub repo, so if you guys just want to find this link, I'll leave it up for a second just to make sure everybody gets there. That's where all the notebooks for this tutorial are going to live. So they're ordered like 00 through 06 or something, which is going to correspond to 1 through 7 of the sections that we'll go through. Everybody get to the GitHub page or question? The first notebook doesn't load. Are you guys using, they're in IPython.
Are we talking about the 00 notebook?
It works for you. Are you using IPython 3? IPython 3? Or, okay. And are you using IPython 2 or 3? You're using 3. Okay. How many people can get the first notebook open? Okay. How many people can't get the first notebook open? Oh, yeah, sure. How to open the notebook, you mean, or? Okay, sure. So are you familiar with IPython? Okay, cool. So it's at this GitHub repo, and what you should see there are these notebooks. And we're talking about just opening up this first one to go through. So if you just download that onto your computer and then open it with IPython. And the way that you would do that is a little breathy. If you're in that local folder on your machine, you just look in there. You can start up IPython notebook, and then you can just click on it to open it. It should work like that. Yep, sure. Does anybody else have questions? We should all be kind of on the same level of opening up notebooks and making sure we can run the stuff we're talking about. Okay, I'm going to move on. You can find, as long as you have this link, you should have a link to everything. So the presentation is going to get broadcasted live to you guys. So if we're on a different screen and you lose a link, if you just navigate to this, it should be /live actually, on slides. Let me post that. So basically, if you're at this URL, with the live pound, it'll kind of update on your computer if you feel like following along there. We have some links that you might want open on your computer while we're doing other stuff up in the presentation. Okay. Also, we were told that we need to try to force you guys to fill out a survey link on the tutorial. So please fill out the survey link on the tutorial. That's also on the GitHub README. So right up here, the tutorial survey link on that GitHub page. So you could find that. And at some point, if you don't mind filling that out, that would be awesome. So let's start. So why we're here, we're going to talk about the idea of good visualizations and bad visualizations and noise and kind of the art of sharing. So trying to take a bunch of data and allow people to explore that data in a non-noisy way so that they understand immediately what's going on in a figure, and then they can also drill into it and kind of explore as they look at your data. So when you have a static image, everything on your plot that you want to convey to some end viewer has to be there at the same time. So you can't hide anything. In this case, this is a plot of movies, and I'm trying to show two things about movies, the runtime versus the rating that it's given. But I also want people to know what movies I'm talking about. So I need that information on the static plot, but this is totally an unreasonable way to visualize that. If you make the plots interactive, then you can reduce all that noise and allow exploration. So if people want to know one particular thing at a time, they can look at it. So here's that exact same plot, just with all that information on the hover. So, oops, I should hover up here. So now this is a plotly plot with that same information, and this is just embedded, and you can kind of see how you've taken all of that extra information and possibly extra dimensions, and you've shoved them into text that comes up on the hover. And this is a really good way to take a bunch of data, and a viewer can then parse out exactly what they need to see, and they can see the overall shape of the graph first, and then they can drill into seeing more. So in this particular plot, this is another example. This is a plotly plot talking about flybys of minor planets in the outer solar system. And it's separated by what the craft is and the distance from the sun when it had the encounter, and the distance of the thing from the craft when it had the encounter. So here you get to this. I just really like this user, Alex HP. He's always doing kind of astronomical plots, but in this one you get to see kind of the overall view of this data. But then there's also a whole lot of information that's kind of embedded in here in all these different points. And all you need to do is kind of cruise around and hover around and look at them, panning and zooming and all of these things. So it's just a really clean visualization, easy way to add a lot of data to the same place. So I think everybody's good with the setup. I'm about to dive into a notebook. I would suggest making or cloning that GitHub repo and just kind of sticking these somewhere. What's going on?
Quite a few people are not familiar with like cloning.
Okay,
repos.
great.
So I mean,
Let's
make sure that
let's do that.
yeah, everyone's on the same page. Some people don't have Git installed, so I recommended downloading the zip.
Okay.
Extracting it afterwards. But yeah, we're just gonna make sure people have the files because not everyone.
Okay, great. So if you do have Git, let's do this real quick.
Have like the whole repo like downloaded locally, cloned or
So if you do have Git installed, you can go ahead and do this. I would suggest making a folder in your home directory and calling it, go for it.
I just wanted to say like please help each other if you have a neighbor who is competent.
Yeah, we'll take this first section slow just to make sure everybody is on the same page. So if you do have Git installed, you can go ahead and clone the repository. So I would make you can just clone it. Let's just do that. So this is one way to do that. Oh, I'm sorry. Thank you. I don't know if that's going to help because it's very little. How about that? Yep. Okay, so if you do Git, is that still too small? I can make that bigger. Okay, that looks better. So git clone, and then you just put this in, and that will just clone it right to the directory that we're talking about. So now you can find that. So you can cd into PyCon 2015, which is where it will have cloned it. So again, it's just git clone and then the URL that we're talking about. And then you can cd into that directory. And I have to go into a virtual environment, but you don't have to do this. And then once you're in here, you can see all the files, and you can run IPython notebook from there and open that up and get the notebooks.
So who doesn't have all the files?
Okay.
Download and having like a file.
That's fine. We can do that too. So let's talk about if you don't have.
Then it's like not a proper JSON because it's like it's saving the link, like the URL or something, not the proper file.
On the NB viewer links. Have you guys tried the NB viewer links? So if you, for those of you who this is a problem for, if you click on these notebook links, has anybody tried doing that? So it'll bring you to an NB viewer site, and then can you download it using this? Does that work?
No, I was mentioning they were trying it from like the what's above in the repo, so that would not work.
Oh, I see. Gotcha.
They found themselves with like foreign files.
Oh, I see. Okay. So is this for those of you who are having a problem opening these or getting to the files? Is this a reasonable way to download it? Does this work for you to come here and then just download the notebook?
Like this is a rendered version of the notebook, but then you can access the source through the page.
Maybe we should actually take a second and both of us go around and figure this out real quick. Okay. Who else in here is? Can I help out real quick?
Live link of the slides
Yep.
where
copy that bigger in the terminal. I think this is blown up. So it's this URL here will find it for you. So it's /live/ should get you the live version. I'm going to keep going around for a second. Does that work for you? I see. When I put it in the terminal, it escaped the hash. There should just be a unescaped hash there. Sorry about that. Okay. Else, can I jump in and help out real quick? Okay, cool. Were you able to upgrade to? IPython 2. I was trying to be cute in IPython. That was probably a bad idea. It's IPython 2. So I don't know why Conda wouldn't upgrade that for you. I'm not as familiar with it. All right. Sorry for a bit of a rocky start. Oh, I'm sorry. Were you gonna? Let me grab that again. So. Okay. So I'm going to continue on, and I'm going to assume that we can get into that first notebook that we were looking at, the 001. So if you're following along here, you guys can click the audience link. I just have it open to a kernel on the other side. So in this notebook, we're going to make our first plotly plot in Python, and that's going to use the plotly package. When we talk about plotly in lowercase, that's referring to the package, but there's also the actual plotly website that everything communicates with, where all the data is actually stored. So we're going to be making calls to Py. So when we import plotly.plotly as Py, this is basically the module that holds all of the communication with our servers. So just kind of organizationally what that means. So let's go ahead. Let me clear all the output first. Okay, so let's import plotly and let's print our version out. If you guys are on a lower version, you can do a pip install plotly upgrade. At this point, we had a change yesterday where we upgraded the version, just a couple little things to kind of enhance some of this tutorial. So you actually might want to upgrade it. There's one spot in here where there's like a save feature we added to the widgets, which is kind of cool. So try to get to 1.6.15 by doing a pip install upgrade plotly if you can. Okay, so the way plotly works with credentials is that you log into plotly at some point and create a username, which you should have done. And then if you followed the getting started, it will have saved a file onto your computer, and that actually gets loaded during these sessions. So you don't have to sign in or anything. It just kind of happens under the hood. So all of the communication with plotly is authenticated with a username and your credentials from that file. And this is what your kind of credentials file looks like. It's just got username, stream IDs. We may or may not talk about streaming in this session, depending on how far we get. and then the API key. So mostly what we care about is the username and the API key. So we're going to refer to data lists or data arrays in Plotly. The basic Plotly figures are constructed with a data array and then a layout dictionary. So a data list and a layout dictionary. Each object in the data list in the Plotly module is basically just a dictionary of key value pairs of either data or attributes that you want the trace to have. It's just how that's organized. And we'll get into that a little bit more. So if you're running along with me now, you've made your first plot. So this actually lives on Plotly, and then it gets embedded back into the notebook. So basically, we just serve you the JS library, and it embeds in the notebook in a little iframe, and that's what you're seeing here. So when you're interacting, this is all client-side, it's all drawing client-side, but the data, when you actually do this, is getting served from our servers. So to do this, we use the iplot command, which wraps plot, and basically all plot does is grabs your credentials, grabs your data, makes an API request to Plotly that saves something in the database, and then you get the response, and then we embed that response. So when we run this one with just plot, this is all that we really care about is this URL. So everything, whenever you're sharing things in Plotly and you want to share a visualization you've made, if it's converted from a matplotlib figure or you've made it just in Plotly, you can share this persistent link to anybody, and then we keep that forever unless you delete it. And if you follow this, it'll bring you to the same thing in Plotly. And then once you're here, if you want, you can edit it in the GUI. So some of this you can do programmatically, some of this you can do in the GUI. It's kind of a nice learning curve, so you don't have to kind of fend for yourself with every single thing. This is a nice way to do it. So I'll just change something really quickly. So maybe I'll change the marker to something different, and then you can save it. So that's that. I talked about data and I talked about layout. So layout takes this form of just a dictionary. So we can get into this later, but one example that you'll be using a lot is title when you want to add a title. Actually, can everybody see this? Is this too small up here? Too small. I'm sorry, guys. Where's that? Okay. Okay. Is that a little better? Okay. Cool. So layout, again, we have title here. You can just add your title to there. And then a figure, like I said, was comprised of data and layout. And so you can actually just pass a whole figure object into iplot or plot instead of data. So the iplot and plot commands will take an array of trace objects, or it will take a whole figure. Like so. So there's that same plot again. And, okay. So now there's a couple, yeah. Yep. This one I saved over. It won't update in the notebook because it's rendered client side. So there's nothing that's connecting that. If you reload it though, it will. So let's see. I called this one iHeartPlots1, and this one is iHeartPlots0, and so is this one. So if I were to go back here to home, and then shut this down, and then open it back up, now it's a different color. So it's rendering again in your browser. So when it did that time it had to get the data again from Plotly. So now it's updated. You can update things live with streaming, which we may or may not get to today. But yeah, this is the early simple version of it that you'll be using the most. The other thing we'll get into later is another workflow. Instead of constantly sending things to Plotly and waiting for a response, and then if you want to iterate on it, you send it again to Plotly and you wait for a response, which is can be really slow if your data starts getting even a little large. You can use widgets instead in IPython, and then it's all client-side. Since you already have the graphing library sitting in front of you, it's embedded in that iframe. We have an API to talk through that iframe, so you can just iterate super, super fast, and you can kind of play around with stuff and link up widgets, and we'll show you that later. Okay. Oops, I should probably run these again now. Oh, yeah. What's the warning? Are you, what's that? Oh, okay. What link are you talking about? Okay. We can probably figure out the warning later on. For now, it's just like a pink blob for now. I probably won't get into that. You can filter the warnings, and I'm sure there are ways to fix that. But was there another question? Blocking? Okay. 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 Well, this is a fairly long intro, and we're just kind of moving through bits and pieces here, so maybe that'll work itself out. Okay, so I'm gonna wrap up what we've gone through so far. So the plot command I already explained is making a call to Plotly. You're updating your own profile with, or not your profile, but your own data on Plotly when you make that command, or when you call plot or iplot, which wraps plot. And then that information updates, you get a URL back, which is the same thing you can share with everybody. And then you can embed that anywhere. We embed it in an iframe in the IPython notebook, but you can embed that by just going to .embed. So let me show you that real quick. So at any time for any of these plots, you can always just do .embed to get the exact thing that we're throwing into the IPython notebook, which is useful if you want to put that in a website. Okay, so now I'm just going to run through. Maybe we can use this time for if people are kind of on different levels, you might want to run ahead. I just have a bunch of challenges kind of in the notebook, and maybe you can work through, and we'll take 15 minutes or so to try to get everybody up to speed, and you can work on the challenges if you're feeling comfortable, and we'll kind of make some rounds. So they're basically just making a bar plot, a histogram, some line plots, trying to work with a bubble chart, and I'll go over the answers in about 10 or 15 minutes. Yeah, sure. Yeah, sure. So we have an enterprise model if you want to keep all your data on your own server. So you're not going to be able to have a copy of what exactly is in our database. There's kind of a lot of extra metadata about all the things. What you can get is the content of our files. So we consider plots and grids, grids being like spreadsheets. Those are files in like the Plotly ecosystem. And what you can get from those on your, like you can pull down all the data that's embedded in that file. So for instance, if I grab a link here real quick, I'll show you this. Okay, so I'm just going to pull this back into Python right now, so you can use getFigure to do that. And you can just dump it a string URL, and that will return a figure to you. And then if you want to look at what you just pulled down, What's that? Oh, right, sorry, for Python 3. That's right. And we'll look at this a little bit again later. You can see that's all the data you had. So you can do that with any of your graphs, and you can keep that locally if you want. And you can always recreate the same figures with that once you've pulled it down. And you can do that for anybody. So the same thing with So right now I'm just grabbing somebody else's figure. Maybe I want to check it out, and I can do the same thing there, and it's all right there for you. Yep. Oh, if you want to protect it, you can make it private. Yeah, yeah. So when you make a plot, so okay, so any of these plot calls, you can just set world readable equals false, and when you do that, it'll be private. So let's do that, and then I'll follow the link, and I'll copy it, and you can't see it because it's private. Yep. Yeah, exactly. Yep. No problem. Okay, I'm gonna walk around and see if anybody has questions about the challenges or about getting set up again.
I'm just following up with the previous question. Can we do all of this locally? Can we do the rendering locally?
You can. Yes, you can do that. That's another workflow. So it doesn't get you so much up until you want to share it. So most of what Plotly tries to do is allow you to share your data visualizations with people online and collaborate with them. But if you use the widget framework, which I'll show in the last section, you can actually just render everything live because you basically load up. At one point, you have to make one request to Plotly, which is to load the blank iframe with a blank plot in it. And then you just use what was all the tools that were delivered with that iframe, and you use the embed API is what we call it, and you can just update that plot iteratively, and that's all local once you're there. Yep. And then you can save that or click through and save it later. Yep. Still having a problem? So I'll just shoot you right to the link, so open up a new tab. Any other questions? No go. Are you guys working on the challenges? Okay, maybe I'll just kind of make some rounds and see how everybody's doing. Okay, maybe I will go through some of these challenges right now, and then we can pass off and start the new section. So there's a question about the alternating bar colors for this one right here. So it says change this so that the colors cycle between. So you can change any figure, or you can change the colors just by sending an array to a style. So you could make all of the markers a single color by adding the following. Marker. Red. So you can add them all like that, or if you change it to an array, it will use that. A list. So you can see that the first one changed, but the rest of them didn't because you have to actually specify it for all of them. You can over-specify though. So in this example, what I did for the solution is something like this, where you just make it really long. And then that's something like that, but with the other colors. Let's see what the other challenges were. So the make some lines challenge, this one asked you to use markers and lines. So by default, you're going to end up with lines here. And I'll change world readable again. Or I'm sorry, by default you get markers and lines, but you can change the mode of any scatter plot by just concatenating it with plus signs. So for this one, you need to do lines plus markers. Just small hint. Again, if you want to do the bubbles, I'll just add one of these. You can add that down here by just adding arrays to the marker. So anything that's style in Plotly, if you make an array, it'll just iterate over each point. So I will make the size equal to S. And now we have some bubbles, which is fun. And there are other things to add there. Rebinning on a histogram, this is an important one. If you just want to specify the number of bins, you can do n bins x or y. And so for this one, we'll do 10. Now it's fewer bins. Very important command. If you need help, you can just ask for it. Not like that, though. We have pretty decent docs, so it'll give you an example, and then the nice thing is that it'll give you all the valid keys that you can use, so you can kind of see what each of those do. So for this solution, you could have looked at this and scrolled down. It's a little funny because the size of my notebook's enormous right now. But you could have found n bins x, specifies the number of x-axis bins. Okay. And then making logs, you can just specify the other axis to be a log. And now that looks a little more familiar if you've done signal stuff. And again, the challenge answers are on the bottom. Any questions about the challenges or need any more hints? I think maybe we should move on to the next section. Okay. We're going to do a trade-off for the mic.
Hello. Okay. Thanks for engaging in this hands-on workshop. It's a lot of work for us, but mostly for you too. We know about this. Because visualization usually comes with data analysis, either like at the end as kind of an output for your analysis, or like at the beginning for exploration, and anywhere in between. We're going to combine a bit of like visualization and data analysis. So for this, where's my mouse? I forget. Yeah, so I have to go down. Yeah. Yeah. I'd like to ask, how do I switch? Oh, yeah, right. Okay, sorry. Yeah. Amazing. Okay, so if you could open now the next IPython notebook, 01_challenge. Yeah, there are version things between IPython 3 and IPython 2. So yeah, for some of you guys, I've noticed like a few things are not working. But you know, in any case, as long as you have the IPython notebook running, you can always just open a new notebook. Oops. And then you'll get, you know, something completely empty. But in those code cells, you can absolutely, and you should copy paste whatever you have from the rendered version, right? So if, because I've seen it for like quite a few people, the GitHub repo, you know, is there. PyCon. And you have these links to the rendered versions. So you can always click this, see what's going on, follow through, and copy paste, you know, whatever you need to run from here, okay? Oh, Command C. So either running things here in an empty notebook, or like from like the pre-filled version, please like try your best. So there's a very popular library in data analysis called Pandas. Actually, it's very much inspired from R, and I just say this because on a day-to-day basis, I program more in R than in Python. But it's really great. It brings the best of both worlds. So I suggest importing Pandas. You could actually do pretty much all of this with NumPy. So Pandas has data frames as like very convenient 2D data structures. So a data frame, you know, is something like this. Data frame. So like the keys are typically called dimensions. It's like a dictionary. Let's say I have those values. So that's a data frame in Pandas. If I give it a name, let me call it df, then I can access a dimension by specifying the key, just like you can do for dictionaries. Oops. Sorry, X, yeah, I didn't call it AB, I called them XY. And NumPy arrays might be more convenient for when you have like more mathematically intensive things to do, to manipulate on. But data frames, you know, can have dimensions of different types. So maybe X is like a bunch of integers, and Y is a bunch of floats, and then Z is like actually character strings. Whereas in a NumPy array, you couldn't have this. So to have some fun, I suggest we do something kind of real world and fun. So I used some baseball data that you can access here. I copied it into a GitHub repo. So the challenge is to load the data and subsequently So I'll give you some time so you can try it for yourself. But then don't worry, I will give you hints. So what's really convenient in the IPython notebook is that you can always press tab for auto-completion. And this way you can find out about methods and attributes or whatever is available for a given object. So let's say my data frame has all the following methods or attributes available. And same for PD, so my alias for pandas. Well, I know that, let's say, I want to read a CSV. Well, is there something called read CSV? If I start typing a lot, like I see that there's read CSV. So then it's really like intuitive and straightforward. You can just pass the URL here, and you'll be able to load that data as a data frame. So please give this a try. I would like you to get a feel for the data, how you explore it, visualize it, perform basic operations like getting the mean, the max, things like that. I'll leave it on. Yeah. Sure. Like they can make it up. All right, so I think quite a few people have figured out that you could just like call read CSV on that URL as a string. So I'm gonna call this data frame data. And I'm just gonna copy paste that long URL from above. Control C. Control V. Enter. Oh, it's a lot of data. Oops. Okay, and then insert a cell below. Type in there. And then I can get a feel for what my data looks like by calling head on it and have like the first few rows display for me. So there are 24 dimensions: player ID, year ID, AB stands for at-bats, H stands for hits, and in total there are more rows than this. What if I do Control MB, enter? Data. Oh, I can go data describe. That gives me some stats about each dimension. So there are like many values for, I guess there should be an integer count. Maybe we can report on this. Then the mean value, the standard deviation, the first quartile, et cetera, et cetera. Another cell below, Control MB, enter. Oh no, I wanted to have it above here. Okay, I'll do it graphically. I'm gonna check for the length of data. Oops, missing a bracket. Okay, so 97,889 rows, that's a lot. I don't wanna process all this. Plus, looks like there's like really ancient data, like 1871. Maybe I'm not really interested in what the baseball scene was like at that time. So I'm gonna truncate my data, and that's why I was like suggesting let's filter out all years. So the syntax is really straightforward. So how do I check the dimension that gives me years? Yeah. Your ID. Notice that I use autocompletion a lot because I'm lazy and I type typos if I type on my own. So, okay, all these, well, I'm not displaying them all. And let's say I just want those that are above 2003. Okay, so like it's gonna create like a mask of booleans, and I can just apply this onto data. And I'm going to be keeping only the part of my data that corresponds to the year being above 2003. So let me reference this again by data. I'm just going to forget about the rest, okay? I mean, I could give it like a new name, but I'm just going to like overwrite the name data with this. All right. Now, has anyone completed like the third question? Are you all with me? Great. So now that my data set is a little smaller, let me check. Let me check how much smaller it is. It should be more manageable and take less time to compute. So how do I access the dimension for add bats? True, there is another syntax. I don't use. Like this? Yeah, it's a little more fragile because yeah, if your name is a character string with spaces, that will be confusing. But yeah, you could do this, but let's say I'll stick to the more robust version. Oops. So indeed, like you want to call like something on your object, the mean method, and there we go. Same for hits. Control M, B, no, above. Control M above. No. Data. And I could also call, you know, standard deviation. Or I could call max. Many hits. And then something visual finally. How do I make a histogram to show the distribution of AB? So pandas is really nice. It comes with all these like things ready for you to use readily. Just hist. Oh, I need to call, matplotlib inline so it displays. So let me control M above. No. So there's this magic command, matplotlib inline. We'll be doing a bit of matplotlib afterwards, knowing also that you can convert matplotlib figures into Plotly interactive ones. So that's really interesting, and possibly you guys already have like scripts and code that generate matplotlib figures. And basically, pandas wraps matplotlib, or at least parts of matplotlib, so that you can have basic visualization when you do your data analysis. So, and then I just specified this so that my matplotlib figures get inserted within the notebook. Oops, so let me run this again. And here is my distribution with the defaults that matplotlib has. Really rough, you know, it's not a figure that I would ever publish or share, or because it lacks styling. It does not necessarily look very pretty, but we can make so with Plotly. So now please make a histogram for the distribution of AB. Sound. Let's the matplotlib figure be inserted within the notebook and show here. Otherwise it could, you know, like pop at, like, I don't know if you've used matplotlib before. Okay, but otherwise it would like pop up as like a separate window, or it didn't show unless you specify it, depending on your settings in the .matplotlib RC, etc. Okay. Hello, hello. Okay, so I saw a few like successful experiences. Um, so how should I go about it? Okay. Well, okay, so first of all, I will need to import some stuff from Plotly. Okay, I'll just move them up here. So what did you type? Very good. PyCon, history. Let's try that. Ooh. Dict error. Data. Oops. Yeah, you want to trace. Yeah. A list of trace, I mean, yeah. Yes, I could. Oops, yeah, I'm not closing my. Yeah. Do I have an extra quote somewhere? Oh, thanks. Woohoo! Okay, so we can see that the binning is, the default binning is very different between matplotlib and Plotly. Not that one is better than the other, but at least you can notice. We can change we learned how to change the X bins here. So which value should I give it? Let's give it something in between. This was like 100, I don't know, let's say 50. Oh, it's not the right syntax. N bins? I should run help. No, okay, I need to run help. What? Oh yeah, okay. But let's pretend I don't know yet. Where am I? Yeah. After this error message, yeah, I definitely need to run help histogram. Oops, sorry, hard to type live. X, Y, and y-axis. Did I miss it? I missed it. Oh, let me do Control F. X. I know it starts like this. Okay. X bins. Yeah, I don't have to specify it. Yeah, so isn't it what I typed? X bins. Let me check. Yeah. X bins. So what was I missing? Oh yeah, why did I X bins? Yeah, but I think that broke too. Yeah, but that's not what the docs say. Am I missing something? Yeah. X. Okay. Oh. but, okay, can check later, but what, expense? Oh, okay, yeah, here as, yeah, okay, thanks. Okay, I'll just comment that out so it doesn't take up so much room. Okay, so I've changed my binning. Then I could go online, I could follow this link, play with this data. I could edit my graph graphically. I mean, I know we're here to program in Python, but it's also good to know if you want to collaborate with people. We'll touch on collaborations across like other languages or possibly non-technical people who are more used to like clicking here to I can save this. And then please make a scatter plot showing H versus AB. So H should be my Y value and AB my X value. Okay, let me try and see if I can reproduce this. So Control MA. I'm going to define my trace as scatter, where X is data AB and Y is data H. And then py.iplot trace file name PyCon scatter. Oh, not so readable. Well, I didn't have any slowness issues. Sometimes it might be that you need to maybe restart your kernel, which you can do here, or even relaunch the IPython notebook altogether. So let me specify markers for this so that I don't have all these like individual dots connected, because really the line has no meaning here. So mode. Okay, again, I cannot remember, so I'll just look up the help. MB. Oops, sorry, I typed an opening parenthesis. Oh yeah. Control F, marker. Yeah. Markers, or is that just go to mode? Yeah. Okay, so I'll use mode markers. Okay, so no, that's actually a scatter plot. So of course I could add, access labels, but I'm also really interested, like, who is this player, or seeing like more information in that hover text, and we have player IDs in the data set. So now please add the player ID in the hover text info. Again, you can run this to get help. people have figured out how to use the text field, the text key. So here we make use of text and we pass data player ID. Oops, sorry. It's a long line. I should just break my line. Okay. Oops, and let me rerun this. And now when I hover, I also have the player ID information, which is really relevant. And again, because it's interactive, we haven't cluttered our visualization any further, but I can explore this data set in a more interesting way. And someone had a really cool idea about displaying not only the player ID, but also the year. And we tried a few things, like having a list here as the value for the text key, but actually we don't support this apparently. So let's work our way around it. So anyone has an idea on how we could have this hover text display not just the player ID, but the year as well? Yeah. Yeah, exactly. That was also my idea from liking data frames very much. So we're going to create a new dimension. So let's call this key player year, right? Or year player. And how should we define this? I guess there are different types, but we're going to force them into strings. Control MA. So that's a string, but that's probably an integer. Yeah. So could I do this? Playing with Python's looseness in type, not as loose. So I'll force it into a string. Or can I go str? Just, oops, where am I? Oh no, this one I want, yeah. Yeah, but apparently, oh, yeah, I'm just, okay, and I want maybe a space here. Yeah. Okay, so I'll do this for all dimensions, for all rows, excuse me. Oh, actually, look, I just noticed this dimension, what is it? Data player year? No? Oh, no, right, that's the one I'm creating, excuse me. Plus a space, plus string, data year ID. Okay. Now if we check the head of our data set, I have to move this way, but, oh wait, it grouped them all together. That's wrong. I have to do it by slices. Maybe like this. Wait. It's not clear to me. No. What was, let's see, zip. And this is like confusing. I think so. Okay, and make this a string? Or oh yeah, right. Yeah. Okay. Yeah. And that will be a tuple? Yeah. And so what if what does it look like now? Okay, well, actually, yeah, it's almost more readable than something with just a space. Directly. But we tried, didn't we? Like, did it work for you here to pass the zip function in here? Yeah, we must have messed up something. Okay. Let's see. Run. This guy. Woot! Yep. All right. Yeah, so then, yeah, this, it's only like a 2D plot. It looks like really simple, but, you know, you actually have much information. You have at-bats and hits and player names and years. And again, you can even style it further, especially in the GUI. It's very easy. And that's pretty much it. We're around if you have any questions, over coffee break even.
I think we'll do the survey thing, the options, and then we'll do a coffee break, and then we'll.
Yeah, absolutely. Pass it on to Andrew again.
Cool. Okay. So we're almost at a coffee break. It's coming up very shortly. I'm going to do a survey of some of the options you have for visualizing data. So we've talked pretty much just about Plotly and then a little bit of matplotlib via data frames because it kind of sits on top of that and you can plot from a data frame with matplotlib. So let's go over some options you have. So matplotlib is something we'll go over as soon as we get back from the coffee break. I'll go through how to do some simple things and manipulation on matplotlib figures and objects, and then how to convert those into plotly objects if you want to share them online. There are other ways to convert and share matplotlib objects. Plotly is just one of them. So we've already talked about plotly. So again, matplotlib is like time-tested, super old. Robust is may or may not be the best word for it, but it's well tested and there's a huge community around it. Plotly allows you to do things that are online and shareable, and you can collaborate with other people, and you also have this data store for it, and you get this persistent link that keeps all your information, your plot data and the visualization together, and then you can collaborate with other people, which we'll talk about shortly. MPL-D3 is a project by Jake Vanderplas. It is matplotlib plus D3. So basically, it's on some levels a little difficult to get what you want done in it, but it does allow you to share stuff online. It's pretty flexible, so it's fun to work with, and you can kind of build interesting things in JS from it. Exactly. Seaborn is something else that sits on top of matplotlib, basically a way to standardize the prettiness into statistical figures. So these look really nice, and you can check out these links. It's something you can install as well. ggplot is coming from ggplot2 in R. It's a port of that. So if you're a grammar of graphics person, you can use this in Python. Again, this sits on top of matplotlib. And then there's also Bokeh, which is a totally separate thing that exists. And you can also visualize data using this. There are some converters as well to go from matplotlib into Bokeh. So we just wanted to give an overview of many of the rich options you have for visualization. Again, we're focusing very specifically on matplotlib and plotly in this tutorial. So let's do a coffee break, and then when we come back, we will have a lot of information about matplotlib. Cool. Yep. All right, I am going to hop back into the presentation. So we're going to continue on with matplotlib. This is going to start pretty low level. We're not going to cover anything crazy in matplotlib. This is basically to get people up to speed with how the simple portions of matplotlib works. And then we're all going to learn how you can convert a matplotlib figure that you already have into a plotly figure. Small qualifier, we're currently working with matplotlib to change how they do their, well, basically add a serialization process for them so that they can serialize their figures. And what this all means is right now there's a subset of plots in matplotlib, which is large, that just won't convert to plotly figures. Most of the simple ones will work right now. And we're trying to work with them so that third-party libraries like Plotly and Bokeh and MPLD3 can all benefit from having a more easily serializable matplotlib figure. So it's kind of in the future, and it's slated loosely for July when that'll happen, but we're working towards it. Before there's a bunch of questions that are specifically like, this small thing didn't render just so, but okay. So a little bit of background. How many people have used matplotlib in here? Awesome, that's great. So we can cruise through this pretty fast. Basically, the idea behind matplotlib is that you've got a canvas that you need to draw on, a renderer that knows how to draw on the canvas, and then you've got these things they call artists that know how to use a renderer to draw on the canvas. So a figure or axes or an axis or a line are all considered artists, and they know how to use a renderer to display themselves on the canvas when you call draw. So we'll get right into it, and you can find this link under, I'm going to open, let's go to the GitHub page. So we're going to open up the Intro to Matplotlib notebook. I'll clear my output cell so this looks more interesting. Oops. Okay, so first thing, you import pyplot typically as PLT throughout this. I'm going to use the syntax of fig, comma, axes equals plt.subplots, and then I'm going to call methods on the fig and axes object in matplotlib. There are other ways where you can use it more MATLAB style, where you just have this figure or current axes that whenever you call function, it just acts upon the current figure or current axes. I don't like that way very much. I think it gets really confusing super fast. So I'm just going to use the methods that are built in and bound to axes and figures to do stuff. So this is for later. It's part of the challenges. MLab, we're just going to use it to fit a normal curve to a histogram. And then this matplotlib inline, if you're not familiar with IPython magics, there are cell magics and line magics, and you basically specify that by using the % symbol, 1 for a line magic, 2 for a cell magic. And this particular one says matplotlib, anytime you see a figure in an output cell, go ahead and display that in the IPython notebook. So we'll see that. So we're going to start super simple, and we're just going to use NumPy to create a time array, and then we're going to use the plt.subplots to create a figure and an axes object. Difference between axes and axis. Axes are basically where you spend 90% of your time. It's got a bunch of methods on it, and that's where you do your plotting. It's where you do your labeling, all these things. And axis is literally just the axis that sits on the axes. So let's make a plot. Nothing too crazy. All I've done here, I've used the MATLAB syntax, I believe, where, well, this is the syntax where you pass x, y, and then specifics about the array. So in this one, I've plotted t versus t, which is just the straight line, and I want it to be red and dashed. And then I've plotted t versus t squared, and I want it to be a blue square, what you see here. And then I've plotted t versus t cubed, and I want those to be green, and the caret is for triangles. So very simple. And recall that I have called this on the axes method, so you can imagine there's a lot of things on your axes, and we can look at that. First, we'll just see what it looks like to set some things on it. So I'm just going to use the set x label and set y label to set the x and y labels. So those are on the axis, the x and y axis. There you go. They're right there. You will probably enjoy using getp and setp heavily, well, at least getp, to see what you can actually change on any matplotlib object. So if we run getp on axes, this is basically get parameters. So it tells you everything about the axes. So these are all the things we can change about it. Adjustable, auto scale. It's got some children, which basically axes are a container for children, like lines. In this case, there are three lines in here, and there are a couple axis objects. And you will see line, 2D, and patch. I should note that there are differences between, they call primitive and container artists. So things like lines are primitives, and they just know, or things like patches are primitives, and they know exactly how to draw themselves, just like a rectangle blob using the render on the canvas. But a lot of the interesting stuff you'll be doing is with the containers. Cool, so let's use this. So we can use plt.setp to change the title. Once again, you can look up here, and we saw that the title is blank, so we can set that. Oops, sorry. Here we go. Now we have a title. I'm a title. On the y-axis, on the x-axis, things are looking good. Another thing that's super common is setting limits. You can do xlim, set xlim, or set ylim to do this. So now I've just changed the limits on that. Again, this is just very simple figure manipulation. Because I think we're all fairly familiar. If we have questions, individuals, we'll walk around and get to you. So the next thing I'm going to talk about is converting these figures. Kind of, even though this is, there's a ton of tools in Matplotlib, and you can do a lot with it, and you can make them interactive, and you can get them to be like more explorable. The default is just a static image, which is, it's kind of a big learning curve to get beyond that. So one thing you can do right now to get immediately into an interactive figure, and then you can change that after the fact, is to do a conversion. So this is basically for when you've got scripts that you found or that are sitting on your computer from years ago, and you want to try to resurface them and maybe put them online or share them in a non-static form, and you want the data to be with them. This is an option for you. So basically the plot or iplot comes with an analogous _MPL command. And this takes a fig, which has to be a matplotlib figure, and it'll yell at you if you pass anything else in there. And it copies the call signature of the normal plotly plot calls. So in this one, we're just going to take this figure that we've got up here. This is our most recent one. And the iplot MPL is going to crawl through the figure using MPL exporter, actually. And it's basically like a visitor pattern instead of a serialization pattern. Converts the figure, and then we take that figure and we send it over to Plotly, and then we embed the result, like usual. So here we've done this, and you see that we've got this nice interactive graph. I'm not sure why. I guess the output cell is very large here, so it went into scroll mode. But at any rate, now you've got this, and you can scroll and or zoom. You can pan and zoom back out. All these things. When you zoom out, it'll auto range on you, which is why the limits went away there. So the next thing you'll want is a way to take a simple matplotlib plot. Maybe it's just easier for you to just get up and running with something simple, bare bones, and then you want to create a version of it that you can share online that's interactive, but you want to add something else to it. You can do that in a one-step process using the update argument. So here's another plot, and this one, matplotlib does the fun thing where it very tightly tries to bound your data so you can hardly see it here, which is fine. But we can change a couple things about this using the update. So this update param we're going to throw as a keyword argument into iplot MPL. Works the same for plot MPL. And what it does is basically after that figure gets converted, the plotly module does not a replace update, but an actual nested update. So the new figure, the update figure, will be used to nested update whatever the conversion was. And it doesn't matter if the keys previously existed. So that means you could change marker colors, you can add titles, all those things in this update, and it's kind of one command. There are other ways where you can just do the conversion and then muck with the figure yourself if you want, but I find that this is a little bit clearer, because you're doing the conversion and then updating it and throwing it onto Plotly. So here what I've done is create an update, which is a figure object. So figure is a Plotly thing, and all figure is a dictionary. All Plotly objects are just dictionaries and lists. So a figure is just a dictionary with a bunch of helper methods on it and a bunch of documentation that says if you build it in such a way, Plotly is going to know what you're talking about when you send it this dictionary. And then the lists are the same way. So the data array or annotations is another list that you'll frequently see in Plotly. I think those are maybe the only two Plotly lists. And they are the same thing. And the nested updates work through lists as well. So I am going to create this update figure. And as soon as I instantiate that, I automatically get data and a layout. So I can use data just like a list, and I can append to it. So I'm going to append a scatter. And remember, what I'm trying to do is build the changes I want to see in this figure. So the change I want to see is that I want these scatters to have hexagram open dot markers, which just happens to be a marker on Plotly. And I want them to be blue. So I add those in. I don't need to add anything else. Again, these are just the updates. And I'm going to update the title. It says I changed this. And I'll update the x-axis and I'll update the y-axis so that they auto-range now, because Plotly will kind of fit that data into the graph by default instead of kind of very tightly fitting the data. So when I run this, we'll pop out and you see it's the same data, and I've changed the title and I've changed the markers and the marker colors, and the limits have been auto-ranged now. So that's kind of a useful thing that you'll run into. Sure. Right, so that's tricky. It's in order that you added it to matplotlib. So matplotlib, when you have an axis, when it has children, the lines will be in order. The tricky thing is that there might be an x-axis mixed in there and blah, 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 but the lines it encounters will be in order. So yeah, it just reflects that. That might end up being a trial and error thing for you. Any other questions? Okay, so I'm actually going to leave most of this time to be practice, and I want to walk around and kind of see where everybody's at using updates and making changes to matplotlib figures. So again, there are a bunch of challenges here. So the first challenge is to make some bars. So here's the original plot. Actually, sorry, this is not helpful. So, oh. Go. Oh, there we go. Here's the original plot. Actually, maybe I'll dump the matplotlib figure first. So here's the matplotlib figure, and I'm going ahead and shooting that over to Plotly just so you can see it. Either way, it doesn't matter. The changes you need to make are make it horizontal, and you can do that in either way you want. You can do it in matplotlib, or you can do updates to change it. Then you can set the title to make some bars, and then label the x-axis and the y-axis like I had before, just to be familiar. Next challenge is, and again, you'll send that to Plotly using the figure conversion. And the next challenge is to do something similar with lines. So here we have this, and we want to zoom in on it. So what we've actually plotted is an approximation to sine. So we want to zoom in on it and change a couple things about it. So you want to change the limits so you can see the stuff around the location you want. There are lots of ways to do this. One way in particular is just converting the figure and then zooming in on it in the GUI and saving it is totally reasonable. Or you can do it programmatically as well. So again, if I want to just zoom in on it, I can just click over here and go, oh, I would like limit to be 2. And I want this one to be -2. And instead of 15 million, this should be 2. And instead of -15 million, maybe this should be -2. And then you see what's going on in the middle. But you'll have to add more things to it, and you should try to figure out how to do that programmatically. And next one, we have the same bubble chart. So you'll want to try to add color and size and some other dimensions in this in matplotlib. If you haven't done this before, it's pretty easy in matplotlib, and we can convert those things. You can do it there or in the update, or you can do it in the resulting Plotly figure. For the histogram, this is where MLab comes in. I find this fairly useful. You can use MLab to do the norm PDF, and it's got a lot of fun things like this where you can fit to histograms, which are pretty cool. And then the log challenge, just making this data look a little more reasonable and changing the log. I just wanted to show you guys the difference between semilog x, semilog y, and log. Whereas in Plotly, it's just you say this axis is log or that axis is log. Just the difference in methods or setting the parameters in a declarative way. So those are all the challenges. The answers are at the bottom if you want to cheat. And maybe you guys can start working on that. I'll show you one thing again. I mentioned it before, the py.get figure, when you want to get a figure and then change it. But maybe I'll just show you that one more time as another means of doing this process while you start working on this. So yeah, and I'll be coming around in a second with questions. Any questions now? Cool. I'm not sure if I've mentioned this yet, but when you're using just the plot, you'll notice that it opens up a new tab in your browser. If you don't want to do that, you can just do auto open equals false, which is pretty handy. And then it won't do that, and you'll just get the URL from the resulting call. very hard to look left at what you're looking at and type forward. Just, yeah. Very bizarre. Suppose I could mirror my screen for this, but that's okay. So here's a couple more things you can do with Plotly, one of which is this a little smaller, py.getFigure. I think I showed you guys before. You can grab any figure off of Plotly by doing that. And then you can do fig to string will basically create a really pretty version of it. And the nice thing, I'll kind of zoom it out so you can see what's happening. It'll concatenate all your lists so that you can see the full figure at once, which is handy. And again, just to emphasize, when you make a Plotly figure, you're doing it in a total declarative way. So this is basically just making dictionaries and lists and sending that over to Plotly, and that's what we put in our database. Well, actually in Amazon S3, but okay. And now, once you've done this is a workflow I often use, which is get a figure and then look at the figure and then make a change to the figure and plot the figure. So I've gotten the figure, I'm looking, and maybe I see show grid is false, and I can change that by just mucking with the figure. So I'm going to go in and change the layout, and then I'll change x-axis, and I want x-axis to have show grid, and that should be true. Instead false, and there's no x-axis. Great. Oh, x-axis 1. We could name it the same thing. And then whenever you name something the same name in the Python library, it will assume that you want to overwrite if that file already exists. So it's always a good idea to give a file name, or else your profile will look like mine on Plotly, which is disgusting because I make a lot of plots. Unfortunately, it will take a long time, and it'll have all of this random stuff in there that you don't really want to show people. So always use a file name. Okay, so very simple. I just turn the grid on for the x-axis. But again, that workflow is kind of useful to take a closer look at, because you grab a figure that you are collaborating with somebody on, and then you can print it, see exactly what's going on in it in a really clear way, and you can see exactly what you need to change, because it's just a dictionary, so you know exactly how to root through there. You change it, and then you plot it again. If you're collaborating with somebody, you'll actually make the change to the plot that you're collaborating on, which is pretty cool. Maybe I should show that real quick. If we go over here to this plot, I can edit it. And when I edit it, I can go ahead and collaborate with people. So I'll just share with Marianne on some plot. Marianne 2. Great. So when you share, you can make your graph public or private. I showed you the world readable thing before. That's the equivalent of just clicking this. So same thing. So I'm going to leave it public, and I'm also going to share it with Marianne. Marianne 2. And add her, and now she can edit it. And when she makes changes, it'll actually show up in my plot. There was a question before about can you have somebody updating data for a plot and somebody else changing the styling on a plot? That's a workflow that we hear about a lot. And you can do that, and I just want to be clear about how you go about doing that. So when you're in Plotly, as long as you have a grid saved for a plot, and this is going to be for everything very shortly, you won't have to worry about this little very specific thing you have to do, which is save a grid first before making a plot to have this apply. But say I save this grid as something and make it public. And now I make a line plot from it. I'm just going to show you what it looks like in here. When you look at the JSON for this, what gets shoved in X and Y are actually sources to that grid. So if you want to collaborate with somebody, you can set that up programmatically, and you can even make a grid programmatically. I'm not going to get into that, but you can do that from Python. And now you've got these sources, so one person can update the styling, and then if you just go ahead and change this to be something like this, and you save it, and you reopen the plot you just made. Oh, except I didn't save it. Just take one more moment on this.
Data updates are manual.
What's up?
Data updates are manual. Like if you have a, say you had a,
You can extend grids programmatically. So you could do this. So this thing that I'm doing right here, you can do from Python if you want.
that's in a data frame or.
Yeah, you can. Yeah, so it ends up being JSON. That's what goes to us. But I'm pretty sure we can handle a data frame or like a NumPy array. We have a custom JSON encoder in Python for that. So again, this is saved.
Code snippet. Do you have examples of that on your website? Doing all those things.
We have examples of doing the updates to add append to grids. So I'll pull that up in a second. Let me just finish this. So basically, I plotted this and then updated the underlying data behind it. So when I look at update me again, all of a sudden we see the updated data. So that's kind of a workflow that's can be pretty useful. One person adding data, the other person styling the graph. Okay, and let's look at documentation for grids. I'm just going to pull up the information on it in the notebook. Import. Don't know, something. So here's the help on a grid. Is that? Yeah, it's viewable. Yeah, go for it.
Like for those who are running Python 3 and not Python 2, xrange is now range. So please like edit your xrange into range.
Oh, that's tricky. So is it a generator? It's just
Yes,
automatically?
yeah,
Oh,
range
cool.
now corresponds to xrange from Python 2.
That's smart. If not, breaking your notebook, I guess, is smart. Okay, so here are examples in here. So it's basically you create a grid in columns, and you can also extend them. And the documentation, this is the best spot to find the documentation. It's likely the most updated is just the help in the actual notebook. So basically you just you create, and then you can extend and append them. And this lives, again, in plotly.grid objects. And the things that live in there are grid, let's see, grid, column, that's it. Very simple, but useful. Okay, I'm going to walk around and see how everybody's doing with the examples, see if there's questions, and then we can go on to the next section. I don't know that we need to dwell any longer on this one. Okay, maybe I think everybody's pretty okay on this one. I didn't see any hands. So maybe I'll just show one quick example of doing the to data frame, which is something that we just kind of worked on like over the last week, just a little bit. So it's not an official release yet, but just to give you a little preview of it. So data frames are super nice, super easy to work with. So we just implemented a simple way to take a Plotly figure. So let's find a Plotly figure online. Let me clear all my output. It's kind of an aside on the tutorial track, but I think this is kind of cool. So we'll take a moment on it. So I found a Plotly figure maybe that has some interesting data that I want to inspect maybe statistics for. In this one, just some pricing. So I will grab the figure first with get figure, like I showed before. And then I'll just run fig to data frame. And then just because it doesn't handle, well, maybe I'll just do that first and show you what's going on. So do this, and I have the data frame now. And I can do df.head and look at what just happened. So basically I got back X, Y, and it's not in a great format, but it's what you have, and you can then kind of massage that in pandas to do what you need to do. I'm also going to replace these empty string values with NaN, just so that we can run describe on it in a second. And then down here, super fast, you can look at the statistics, which is pretty cool if you think about like where you would be if you just were looking through a paper and you saw a static plot and you're like, I wonder what the distribution on the data is in this static plot. I'll never know. So this is pretty nice if you happen to find a figure and if people are sharing figures up on Plotly where the data is together with it. Really fast, you can find some simple statistics and then use pandas to kind of drill in and make different plots if you want to off of it. So that was just a quick aside, but some fun stuff that we're trying to do to integrate a little better with pandas because it's so useful and a lot of people know how to use it very well. So, okay, that was just a quick aside. Anybody have any questions about the matplotlib or about the to data frame at this point? So I think there was one issue maybe somebody had with updating to the new Plotly and to try to get this to work, and maybe there's an import issue. This isn't an official release, so there's just a little bug that got through there. But you can look for this in the next GitHub release on the Python API repository on GitHub. Okay.
Okay, so now I would like to touch on workflows and collaborations and exploration. Reproducibility, We announced it in the outline. I would say like the main thing I can leave you with is that, you know, the IPython notebook is a very convenient environment for computing, and you know, you can save it and you should save it. It's very convenient to keep like hard-coded code snippets. But then of course, this brings into play, you know, larger frameworks like version control, etc. So of course you should use this. You should use version control to have reproducible workflows. But here we're touching some more on the exploration part of data analysis and visualization. We're gonna go through like real world like example where, let's say, I'm very inspired by this plot. Oops, let me run this cell. Oh, the colors are, oh, yeah, colors are not great. Like visually, it looks a lot better in your screens, I hope. But this is the kind of graph that you could see in the New York Times or anything journalistic. Yes? Okay, someone will come. Yep. So this is visualizing a really big data set that's been aggregated, but that compiles calls to 311 in New York City, so complaints of all these kinds. And already thanks to the interactivity, I can, you know, hover and look up details. So at 9 a.m., most complaints are, I guess, from like the other category, so that doesn't say much. But let's say I want to filter out other because, okay, now I can see like actual content. So this legend here is interactive. It lets me filter out the things I'm not interested in. And this is already like a lot of exploration you can do very cheaply. And with what we've shown with getFigure, we can go even further and retrieve all this data and all the plot information and maybe massage it into something else, because after all, you know, a data visualization is here to tell a story, and you might want to tell it, you know, in a better way or in a different way. So how do we get a figure? Well, with the getFigure method. So let's run this. As Andrew showed, we have this like very nice way to display what's in there. So the data list consists of a bunch of bars. You know, the category for the complaint is found here as the name. So there's a lot. So basically, each bar trace here corresponds to like every single complaint category here. So for graffiti, I'm removing it here, but like adding it here, you'll have as the X values all the 24 hours of the day, and as the value, the Y values, the number of complaints for that category. So like here, there are none for like many hours of the day, and somewhere like later in the day, you have graffiti complaints. Okay. So I can list all the complaint categories with a simple list comprehension. So these are my character strings. It's about building use or noise or dirty conditions, etc. So now I'm thinking, okay, I could kind of see like the relative importance of you know, number of complaints per day. I mean, they're more concentrated towards the middle of the day, but that's only one way to display it. And I think that if I have a heat map with the actual complaints on one side and the hour of the day on the other side, I'll be able to visualize in a better way when a particular type of complaint is more important. So I'm just going to use that same data, but to visualize it in a different way. So I invite you to do it alongside myself. So we're going to use the heat map object, different type of plot chart, plot or chart. And now, well, actually, I'm going to call the help function on it to see how I should use it. Help heat map. Okay, it's a dictionary-like object for representing a heat map trace. Okay, and it takes like Z, X, Y fields. Z is required, whereas actually X and Y are not required, because you could visualize directly, you know, just like you have a matrix with like values, and you could have the heat map for it without knowing, you know, without giving X or Y specific names or values. So please go along and, well, I've made it for you here, but define a heat map trace using all these numbers of complaints. Big data. And here we go. Okay, so there's kind of a, you know, a maximum here. And now please add the Y and X fields so that we know what complaint we are talking about, and what, well, hour of the day is already like kind of redundant, because 1 through 24, well, actually there's like, yeah, the index is the same as like the number of hours per day. And maybe then do other changes that might help the visualization, such as using a better color scale. You can do that online with the graphical interface, because as we know, color scales where the hue varies might not be really intuitive for interpreting visually. So please play around with this, and I'll walk around to see where you're at. people been able to just add those X and Y keys? So then if I run this, so I picked the first trace for X because it's all the same. It's always from 0 to 24. And if I rerun this, yeah, then I can see the complaint types on the side. Unfortunately, yeah, it's chopped off. Bit of an issue there we should fix. But at least upon hovering, you can see all the information. And if you wanted to edit this online using the GUI, then I would go edit graph. And I could change a bunch of like style information. Oops, I can't see. Okay. So I'll move quickly because I would like to show something in terms of collaboration across the Jupyter languages. So as I mentioned before, full disclosure, I'm an R programmer. So if I can switch to my laptop, I'll show you something very quickly. But please ask questions if you have any about what we just showed. So like getting a figure and interacting with the figure object, be it exploring the data, possibly changing it or changing layout things, and going from one plot type, in this case bar chart, to another plot type, in this case heat map. So let me see. Okay, yeah, so just showing off a bit about the IPython project. It's turning into the Jupyter project where other languages are supported. Actually, Jupyter is an acronym for Julia, Python, and R. So you can actually run R in an IPython notebook if you started with the R kernel, which I have done here. I'm all set up locally, that's why I changed laptops. So we also have a plotlib package in R. So you can do this like similar things. There's a get figure method as well. It's all lists of lists that you can interact with easily by getting and setting, your values for all these fields. So in this case, I'm using this plot here. Yeah, and I wanted to highlight that from graphical and web perspective, it's nice to have all these extensions that work. Once you have the URL for your plot, you can just append popular extensions, and here you go, you have static graphs like PNG, SVG, oops, sorry. And you also have like the declarative code in Python or in R or other languages, and this is like really convenient. So just wanted to show you this. So basically I'm retrieving like all the plot info. So I also have layout. So $ is the way you access dimensions of a data frame. So layout and data as usual. And I was checking out annotations. Okay, that I have their position. I have like the content, and I can make changes to this. So actually also the assignment operator might also shock you. It's different from Python, and it's actually creating an actual copy of this list. It's not passed by references like in Python. So far the font size is 11. Let me set it to 14. Now if I check, it's original, but copy has size 14. And now if I call plotly, the plotly method onto this like new list that defines my plot with respect to to data and layout, then I'm gonna have an updated version that lives here, and that's supposed to have larger font size for the annotations. Yeah, so this is larger than the previous one. Let me visit it again. Oops. Yeah. Can also show the full display with the embed extension. You can use this to embed, in any HTML, a blog post or iframes that you do. So before, after, which I did programmatically this time in R. So if you have collaborators in R or other languages and you can't convince them to switch to Python, well, it's not hopeless because we're here for you. And you can also embed your plot in the IPython notebook running the R kernel with the irplot method. So yeah, I just wanted to give you a little bit of a flavor for this. And I'll pass the mic back to Andrew for like widget demonstrations.
Okay, check. All right, super excited to show you guys widgets. They're a very fun thing to play around with. Okay, so we've done this, we've done that, we explored, we collaborated, talk about how there's other fancy things to be done. So before I go to widgets, just so we don't run out of time on the other stuff, I just want to mention that there's a couple other things that you can do, including pretty math and kind of nice formatted math with LaTeX, however you want to pronounce that word. And then there's also streaming that you can do with your data. So this is an embedded plot right here, and I can kind of hover over it and actually see the data happening and going in there. And when you stream, it actually pushes live to anybody watching, just like how you're getting the updates from the live view of the slideshow in a way. It's just pushing to you the changes in the data, so you can actually stream to anybody and they can leave that page open and they'll see the changes, which is pretty nifty. We're working towards having that be kind of the default case for all data, so that anytime any plot, the underlying data in a plot changes, you get a little push and it just changes your view of that plot, as long as you're pointed to the right URL. So that's a fun thing. The streaming for now, though, is I mentioned the streaming tokens. Probably won't have enough time to get into it, as in we won't. But just to give you a heads up, you can do that from Python. You can set up all these streams. Basically, there's just a separate server that handles all that. So you need a separate little token, and it's a separate service to do so. OK, so let's talk about widgets. I'm going to open up this one that is 6 widgets. And we're going to look at a new workflow. So instead of doing this thing where you make a plot and then send that data to Plotly and then wait for a response from Plotly and then make another request to Plotly to embed a resulting figure that you then grab that data again, it's a lot faster if you just do it all client-side. So let's just do it client-side. So how many in here have used IPython widgets? All right, I got one. We're going to learn something today. This is great. Cool. So IPython widgets are somewhat new, and they're still kind of moving. They changed a lot from, well, not a lot. They changed a little bit from 2 to 3, and you'll see when I run this first cell, you'll get this warning that says they're experimental and they may change, which means they will break backwards in a backwards incompatible way. But that's okay. They're still fun to play with and extremely useful. So let me clear all the output. OK, great. Widgets. So we get a warning that says you should be careful about using this, which we'll disregard. And so what's a widget? A widget is something that sits in JS land in an IPython notebook. Well, we're talking about IPython widgets. They sit in JS land, so they're in the front end, and they can interact with the Python kernel running in that IPython is running on top of, which is sort of strange. And what happens is that you actually require this async communication, where in Python, you send a signal through this COM channel, and eventually this async reply will come back to you from JS. So you can't depend on things being synchronous, but you can still do a heck of a lot with that, because now you can communicate between JS and Python, and from JS to JS via Python, and all these kind of crazy things, as long as you don't need to depend on things being waiting for a response on something. So the first thing we'll do is just load up a slider. This is pretty cool. I mean, it's a little slider in IPython. You created it using Python, and it's like this little JS thing that pops up, which is pretty strange. And the interesting thing, though, is that we can talk to it in Python. We can just change this value that it has, and the JS will actually update. So when I do this, you see that that changed. This is pretty helpful. That means that we can use this to change, you can use Python to change JS. Okay, well, that's not very useful. The next thing we could do is use let's see, oh, right. The next thing I'm gonna do here is just set a callback. So when you muck with it in JS, it's gonna make a callback to Python that says, hey, somebody changed me, you might wanna do something about it. In this case, the thing I'm gonna do is display the value, the current value of the slider. So I just ran this, and there's this special thing on trait change, which is something all widgets have in IPython. And that allows you to take a callback as the first parameter, and then the trait as the second parameter. So in this one, I'm saying whenever value changes slider widget, you should call display value. So now that I've done that, when I move this slider, you're gonna see Python interaction. So what we first saw was we created a widget, and now you have something to play with in JS. And then we were able to use Python, our own hard-coded Python, to change what the state of the widget is. And then finally, we set up a callback to say whenever the state of the widget changes in JS, do something in Python. Okay, well, that's pretty cool. Let's see what we can do with that. So the first challenge here is basically, can you make one widget change another widget? So to do that, you're going to need to set up a callback where you have the onTrait change for one widget setting a new value for the other widget. What I asked for in this challenge is basically just make it be the sign of the other widget. So whatever the value of the first widget is, make the second widget display the sign of that value. So the first widget goes from 0 to 1. So, or actually, I guess it goes to 2 pi. So when you're over here, we should see this, and vice versa. So where's our 0? Or 0. So when this moves, you should see this cycle through twice. So you guys should start trying to figure that out. This might be a little bit complicated. You're kind of diving in. There's a lot of concepts going on, so maybe I'll just mention this one more time. The thing you're going to need to do is set up a callback and then register that callback with the widget. Maybe I'll just start typing it while you guys work on it as well, and we'll see where we get in a couple minutes. All right, so I'm going to run this and see if I messed up. And now we've got one widget controlling another widget. And just that concept you can do a whole lot with. So the next thing we're going to show is what if we had a graph as a widget? Then you could do things like set up a parameter or a scalar on a slider. And now you can change a graph and make it super interactive. Or maybe you could select different data interactively with a widget. And maybe you ship this to somebody, and then they can see what your data is all about. And they have all these tools to explore, and they don't need to know anything about how to mess with Python or how to visualize. You set this up for them, and then they can run it, which is pretty cool. So this is the new workflow for you guys. Even without shipping it, now you have a way to update things interactively client-side without talking to Plotly. So the first time you call this graph widget, I imported this from plotly.widgets, and it's called the graph widget. So the first time you call graph widget, you can instantiate it with an existing figure. So let's take this and see what happens first. Initializing. Maybe there was a lot of data. I'm not sure. Maybe this isn't a good example. Oh, I see. Thank you. Okay, cool. So now we have this widget that's sitting in JS land, and we can play with it in Python. So let's do graph.delete traces, and we'll delete 0. See what happens. And things go away magically. This is really powerful because that happened instantly. You didn't have to talk to Plotly at all, and you can just update stuff. So let's look at what happens when we instantiate it with nothing. That's just going to give you a blank plot. That makes one request to Plotly and says, give me a blank plot for me to play around with. And it lives at like playground. It's like user playground 7, something like this. So once you've got that plot, now we can update it. So I'm going to just make this smaller so we can see all this happening in one shot here. So first, I'm just going to use plot, graph.plot. That's on the graph widget. And I make a plot. So you can use this data argument, can be a figure or a data array like we talked about before with any of the Plotly modules. And the really cool thing is that I don't need to do anything else. I can just plot something different to it. And it's an idempotent plot. So you can just constantly keep changing things and iterate super fast, and it'll just eat it for you and handle it. And there's now no lag anymore. So what you kind of trade off a little bit of, you need to learn a little bit more to understand how to instantiate this widget. But then you get this trade-off of everything's super fast now. Yeah, I'll do that again. I was just trying to get it to fit. So, okay. So let's zoom larger again, and I will show you one way that you can currently save this. So because you're doing everything client-side, Plotly doesn't know anything about it. So if you want to save it, you actually have to follow this link through, and that'll open up this, you'll see this briefly, this Plotly external. What that's doing is saying, hey, somebody's sending this data in, and it's not been saved yet, so we need to handle it. So this has not been saved, and now I can save it after I'm done mucking with it. So you can basically iterate. Once you have something you like, and you've done that quickly, and you've explored it, and you have a particular view of it, you can save it. Yay. Okay, so let's move on. There's another challenge, fun. This one is just a little practice of trying to do this for yourself. So if you run this and you have the challenge graph open, what you need to do is try to set the x-axis title, the y-axis title, and throw the t and x arrays in there. So you'll basically have a time versus distance and set some titles on it and see how you can do this with a widget instead of just instantiating it and sending it to Plotly before you see the visualization. You build the figure the same way though. So again, a figure is just a dictionary and you just set the parameters. So you've already done this before. This time you're just hucking it into a widget. So I will start typing this as you guys go along. Are there any questions about widgets in general? Or is that confusing to anybody?
Are you going to save the changes you made and push it to the GitHub repo?
These are all, so that's a good question. So the widgets do not show up in NB Viewer when they are ported somewhere else because you can't allow that JS to just run when somebody else opens it, unfortunately. So you have to run the notebook, which is actually a really big qualifier for this. So if you want to save something, you actually need to save it and then embed that plot later in the notebook. So if I did want to share this, say I want to share this one, what I would do is I saved this over somewhere. I'll just do it again. So if I were going to do this, I would consider just embedding this. So that somebody can see what we've done. So it's kind of a drawback in some ways, but you gain a lot from being able to do stuff client-side. Cool. So let's add some stuff to this graph. First, we need to add the t and x arrays. So we'll need a trace. So let's call our trace, and we wanted to do it as a scatter. So we'll do x equals x. Actually, x is equal to t. That's what we want on the x-axis. And then y is equal to x, quite confusingly. And then let's try plotting this. So we'll do, what did I call it? Challenge graph dot plot, and you need to send it an array. So we wrap the trace in an array, and there it is, immediately without having to wait, which is cool.
Yeah, can I interrupt? Just because maybe it addresses the question we had, like to reassure everybody that they can reproduce this or like find references. If you scroll down, there are answers to the challenges. So like, don't be afraid about like losing a few bits here and there, like, and this lives in the repo. So there are answers to the challenges, even if you don't follow quite everything we type. Like,
Yeah, so just at the bottom. Yeah, maybe I didn't realize that might have been the point of the question. Okay, so now we have a line in here, pretty nice. And let's go ahead and I'll just change one of these. I'll change the x-axis title as well. So here's a trace, and for this we need a whole figure object. So we'll do figure equals capital figure, and then figure dot, open close bracket data dot append. So we'll just append the scatter trace instead of making it a new one. And figure layout, and then we can do an update on it, which is a nested update. It's a little bit overridden from the normal dictionary update, and we'll change x-axis to have a title of time in seconds. Cool, so there it is. And I will move on from this. I will note that on purpose, I keep mixing using dictionaries or plotly figures or plotly objects. The cool thing is that you can freely do that and you don't lose validation. You'll still get the local validation as long as you're calling plot. Once you call plot, at some point, it'll yell at you. So if we misspell something, don't know about title, so we see, we just made a spelling error. So that's super handy, and you can mix that because all of these objects are just dictionaries and lists again. Okay, so now we have this cool thing where we said we can have a widget and we can now use Python on that class to just keep updating it. But we also know that widgets can interact with other widgets, so you can have one widget change and then it does something to another widget. So let's have a slider that when you interact with the slider, it changes the graph. So still doing kind of a gravity-themed thing here. I'm going to, actually I should walk you through exactly what I'm doing. So I'm gonna put a figure in there with the plot call. So this is just loading up my initial data. So let me do that first. Oops. Okay, so I've made this plot and all my labels are there, but slider's not doing anything yet because I haven't hooked it up. So again, I need to change the callback so that when the slider changes, I update gravity based on the slider. So now I'll do that. And now when I go up here, I can actually change my graph and the data in the graph just based on this. So you can do calculations after this. You could use this to filter data. You could use this to maybe change a rolling average. Kind of can do whatever you want with these widgets. Anything that you can dream up changing, you're now only locked by the amount of power it takes to draw the image, like in your browser, and the amount of computation power that your computer can handle, which is usually really a lot of computational power. So you can do a whole lot of cool stuff. Maybe if we have time, I'll open one up where I just have a slider that's keyed to like different parameters and a fractal landscape mapping, and you can get like extremely high resolution in 3D and just start tweaking all these parameters all live. When you're done, you just save it. So let's talk about saving for a second. The first thing I showed you, which is when you click through, is one way to save, but it's kind of nice if you can do everything programmatically. So that was following the link. The other thing is that all these widgets come with a .save method. And when you call .save, it'll just blink the plot on you, which tells you that it indeed saved. So let's do gravity graph. And this is actually one of the updates that came in the newest version of Plotly. It's like a beta release. So if you don't have this, it's no big deal. It'll probably be out in a couple days. But we were kind of running through this and realized that there's no reason to not allow you to do it programmatically. So you can do it programmatically. So when you save this, you give it a file name, because it's going to go to Plotly now. So PyCon gravity or something. Do that, and you can see the figure kind of fades out and fades back in. And then once you've done that, you have this new property or a new attribute on the graph. So it was gravity graph.url. Oh, thank you. And so this answers your question. Once you save it, you immediately get that URL back, and you should just embed that. So I would get in the practice of just doing this every time you make a plot, and then you're safe when somebody else loads that notebook. Okay, so I've already done this. Okay, widget interaction challenge. So I'm going to do another one. I was talking about you can kind of update data, but you can also filter things with it and select categories. It's actually really fun when you play with data frames on this, because you basically have a database at your disposal to do queries on, and then you can kind of really get interesting views of the data when you do this. So this is just a very simple version, but the challenge here is to leverage widgets and use this dropdown, which is not populated yet, so that when you select the dropdown, it changes which trace is viewing in the plot. And that's going to use the visible property of all Plotly traces. So any data trace in a data array has a visible property, and you can change that to be false. So I'll start typing that up. Before I start typing, are there any questions on this so far? Cool. So I'll show you what this looks like when there's not filtered. And you can imagine this being the case with data you might get, which is you just have a whole lot of stuff. And you might want to explore it. And once you know how to do this, it's actually pretty easy to explore, and then you can share it with somebody. So let's see what we need to do. We need to first populate the options. So you use options to do so. I think I give a hint about that. Yeah, options attribute. So let's do dropdown.options needs to be equal to, we'll set it equal to the names. So I'll just do a list comprehension here to get all the options. And I'm actually going to cheat, I forget. Oh, right. So this is actually a little tricky. The options requires a tuple. So basically it says if you have this name, what's the value given to that option? So we'll do a tuple of that. So given this trace name, we will do I, and then just enumerate this for I and trace in enumerate. And if you're not familiar with enumerate, it basically says I'm iterating over something, and I'm not only going to give you the element I get, but the index of that element. So now we've done this. And that should have been like so. Okay. So now we have all these options here. They don't do anything, but we can look at what exists in that dropdown. So let's look at dropdown.value now. And it's 2 because we selected trace 2 up here. So let's just validate that or verify that. Okay, it changes to 12. So we know what we can use to filter this. So not only will we do options, we'll set up an update graph. And that is going to, we need to set visible to false to everything else. So we'll do showing is equal to dropdown dot value, which is the trace one. And then we'll do oh, okay, I use restyle. This is tricky. So in this one, I'm going to use restyle, which instead of doing a full idempotent plot, you can actually just update these things. So I'm just going to save myself the typing, and I'll explain what this is. So what I'm doing here is just making basically a bunch of booleans that says if I is equal to showing for I in range len data, then I'm going to use that to update the visible. So basically, visible is a big trace, and when you use restyle, you actually pass arrays, and that will update trace-wise in a plot. So you can run, let's run help restyle really quickly. Help, and then restyle. Okay, so update the style of existing traces in a plotly graph, and it gives you a bunch of information, which I won't go through, but it explains in detail how all these things work. In fact, all of the widgets, all the documentation for the widgets is pretty good. So let's comment this out. And I will run this. And oops, what else do we have to do? Link it up to the actual callback. So we'll do dropdown.on trait change update graph. And we will use the value. So pretty nifty. Just another thing that you can do, and again, you can kind of keep coming up with these interesting things that you can use to explore your data. Or you've got this big data set, maybe you have a lot of traces in it, maybe the traces are huge and you want to do averages over them, or do computations based on something. This is a nifty way to do this. Again, all client side, all this happens super fast, and it's really clean and pretty to look at. Once you plot it, you still have all this interactivity hanging out here, panning, zooming, all those good things. And then when you're done, you just save it. So let's do the selection graph dot save, and the file name will be PyCon selection graph. And you'll see it blink up there, and then let's go ahead and embed it so that somebody later can see all the hard work we did. Okay, and that's it. So that's the widget frame, or the widget workflow. Any questions on that or feedback on it? Basically, it allows you, again, to do all this stuff client side without having to leave IPython, and you don't have to interact over an internet connection, which can take a long time when there's server processing that has to happen. Okay, so I'm going to just quickly recap what we did here. Actually, I'll just comment. You should, again, fill out the survey for this. They really like that if you guys fill out the survey. So please do that. Again, what we covered was basics of matplotlib, how to convert matplotlib figures into a shareable form and throw online. We talked about a lot of different options, including MPLD3, Seaborn, ggplot, and Bokeh, and Plotly, to get things either prettier or in a form that you can share with other people. Specifically with Plotly, we talked about the data store and how you can collaborate across different languages. So Marianne showed that with R and Python, and how you can then also collaborate by sharing those figures with other people and allowing them to actually update. And finally, we talked about the widgets, which is a new workflow, which is super fast and is fun to share with people and allows you to explore your data in really interesting ways once you get it set up. And you can also save those results, pick one and save. So I think that is exactly the end of our presentation. So thank you very, very much for coming. This was fun. I hope you guys picked up at least a couple things or had some new ideas. Cool, cool. Our information is on the GitHub site, so if you want to find us there or go to Plotly, or if you have any support emails or things, you can get in touch at support@Plotly, feedback@Plotly, all these things. Again, I'm Andrew and Marianne. Thanks for coming out to our tutorial.